So in this lesson, what I taught you was how to actually convert between a certain amount, either moles or grams of one substance, into moles or grams or even particles of another substance. Okay? And the way that we do that is by using what's called our mole-to-mole ratio. And so I compared it to a sort of recipe. And the amounts of reactants and the amounts of products, how we compare them, is by simply using their coefficients. So this impresses the importance of balancing properly. Okay, so for this first problem, before I even get started with what I'm being asked to do, I need to balance this. So I give you N2 and H2 react to form NH3. So I've got to balance this thing. H2, I've got 2 H's on my reactant side, 3 on my product side. So I'm going to put a 2 in front in order to get 6 hydrogens. So I'm going to put a 3 in front of H2 here to get 6 hydrogens. I've got 2 nitrogens on my reactant side, 2 on my product side, so I'm balanced there. Now, in order to go from moles of my given of nitrogen gas into moles of ammonia, which it's asking for, I need to set this up properly. So I have 5.00 moles of nitrogen gas of N2. And I'm going to get into moles of NH3. And I know that relationship based on my balanced reaction. So I'm going to put moles of N2 on bottom, and I'm going to put moles of NH3 on top. Okay, so now I can simply use the coefficients. So the coefficient for NH3 is a 2. The coefficient for N2 is a 1. So then the answer that I get is going to be 10, because I'm going to multiply 5 by 2. Well, I want 1, 2, 3 sig figs, so this is going to be 10.0 moles of NH3. Okay, keep in mind that you cannot use your coefficients to determine sig figs. So this relationship here is the only new thing that we learned in this section, and that is called your mole-to-mole ratio. Okay, so let's look at a slightly more challenging problem. So what if instead of giving you moles, I ask you to convert into between grams of 2 different substances? Can I do that? Absolutely. Let's first balance this. So I've got 2 oxygens on my reactant side, so I'm going to put a 2 in front of SRO. So then I need a 2 in front of strontium. Okay. I'm now balanced, so I'm going to write my given, which is 17.8 grams of strontium. And it's asking me to get into grams of strontium oxide. So I'm going to write out the steps off to the side, what I'm going to do. So if I know my grams or my mass of strontium, I can easily get into moles of strontium. And once I know my moles of strontium, I can use my mole-to-mole ratio, which we just learned about, to get into moles of strontium oxide. And once I know my moles of strontium oxide, then I can get into grams of strontium oxide. Okay, so let's actually do those steps. So first, I need to get out of grams of strontium, and I'm going to put moles of strontium up top. Then I want to get out of moles of strontium because I want to get into moles of strontium oxide. Okay, then I want to get out of moles of strontium oxide, and I want to get into grams of strontium oxide. Okay, so how do I do that? Well, I need to put the molar mass of strontium. So the molar mass of strontium is 87.62 grams for every 1 mole. Then I'm going to put the mole-to-mole ratio for strontium oxide and strontium. So that is going to be 2 coefficient for strontium oxide and a 2 for strontium. And then I need to put the molar mass of strontium oxide. So strontium, again, has a molar mass of 87.62. And then I'm going to add to that the molar mass of oxygen, which is 15.999. And I get for the molar mass of strontium oxide 103.6, let's round that to 2, for every 1 mole. So I'm going to take 17.8, I'm going to divide by 87.62, then I'm going to multiply by 2, divide by 2, and then multiply by 103.62. And what I end up getting for my grams of strontium oxide unrounded is 21.050 grams. Okay? 17.8 has 1, 2, 3 sig figs. 1, 2, 3, 4. 1, 2, 3, 4, 5. So I need 3 significant figures. 1, 2, 3. So this is going to round to 21.1 grams of strontium oxide. And that is my answer. Okay. Well, what if, instead of asking how many grams of strontium oxide, what if I had asked how many formula units would that be? Okay, so if I gave you the exact same problem, grams of strontium, you convert it into moles of strontium, then you convert it into moles of strontium oxide, exactly what you just did. Okay. But now, instead of asking for grams of strontium oxide, what if instead I asked for formula units of strontium oxide? Well, the only thing that would be different, okay, I'm going to quickly rewrite what I had down here. So I have 17.8 grams of strontium oxide, grams of strontium. I'm going to first get into moles of strontium. Then I'm going to get into moles of strontium oxide. So I'm just recopying what I had up above. Okay. Now I'm at this awkward point where I'm in moles of strontium oxide, and I now need to get into formula units. Okay. So in order to do that, I know that 1 mole of strontium oxide is an Avogadro's number's worth of formula units. Okay, so now I'm going to take 17.8 divided by the molar mass of strontium, multiply by 2, divided by 2, and then I'm going to multiply by Avogadro's number now. Okay, and so the value I get, I want 3 sig figs. I end up getting 1.22 times 10 to the 23rd formula units. So this is a slightly different problem from the one above because I'm not trying to convert into grams in my last step. Instead, I'm trying to convert into formula units, which you can totally do. All right, let's look at one additional way that I could manipulate this problem. What if instead of giving you the mass, what if I told you, hey, you've got 5.6 times 10 to the 21st formula units of strontium oxide? Okay, so let me show you the setup for this one. Okay, so now I'm going to go from formula units of strontium oxide first into moles of strontium oxide. Okay, and I'm going to get into moles of strontium oxide. Okay, then for moles of strontium oxide, just like before, I can get into moles of strontium. Okay, and once I'm in moles of strontium, then I can get out of moles and get into grams of strontium. Okay, so these are all just different variations of the same concept. Okay, I'm going to put Avogadro's number for formula units on bottom. 6.02 times 10 to the 23rd is 1 mole. The coefficients, again, were 2 and 2. And the molar mass for strontium was 87.62 for 1 mole. And so I'm going to take 5.6 times 10 to the 21st. Okay, I'm going to divide by, make sure your Avogadro's number, 6.02 times 10 to the 23rd, is in parentheses when you divide. And then I'm going to multiply by 2, divide by 2, and then multiply by 87.62. And I get, unrounded, 0.815 grams. Keep in mind, I want to have 2 sig figs because everything else has more sig figs than that. Okay, so this is actually going to round to 0.82 grams. And that is it.